editor for Hadoop MapReduce only, but not to the complete Hadoop. I hope this is understandable. Okay. Okay, so the Spark is a computing engine, and the Spark will provide you the things for batch processing as well as the stream processing, and it is more interactive, and it can be integrated with all the machine learning libraries, everything. Okay, so that's why many of the companies now we are using the Spark. Only very few companies use Hadoop, which are legacy. Like if they are using legacy applications, which have been built long back, they will continue maybe. But all the one which are coming newly, they will all choose the Spark only because it is trending now. Okay, going to the next one. Introduction to Apache Spark. Apache Spark is a general purpose distributed system. Okay. And this Spark is having four languages. In Hadoop, how many languages do we have and what is the language we discussed? Can anyone answer it quickly? Java, right? Yes, Shravanti, you are right. In Hadoop, only one language is being supported, that is Java. In Spark, we have four languages, that is Scala, Java, Python, and R. And this Spark has been built on Scala. Okay, Scala, and it is intended to. It is. Give me a moment. Sorry. So Spark is integrated with four languages. One is Scala, Java, Python, and R. Spark is written on a language, Scala. Hadoop is written in Java only. This is on Scala. That is the major differences between Spark and Hadoop. Till now, you got two things. It can be integrated with four languages. Spark can be integrated with four languages, and Hadoop can be integrated with only one language. And the second one is Hadoop is only it can handle only batch, but Spark can do both batch processing and also the stream processing. So this is the second one. And coming to the next one. So this is the architecture for Spark. You can take a note of this one. Okay, we are replacing only the map reduce of Hadoop with Spark. Rest is same. Even in the Spark cluster, compute is Spark, and storage it can be local, Hadoop HDFS, Amazon S3. In resource manager, you can use Yarn or Kubernetes or whatever it is. It is based on your convenience. Okay. This is the Spark cluster diagram. You can take a note of both together side by side like this only. Then you will understand. When you see the picture, you will understand. This is also most important thing. You can take down this one. I will pause for a minute. You can note it down. I hope everyone has taken the notes. I'll be continuing to the next one. Till now, everyone are clear, right? Please quickly answer here. You are clear till now, right? Yes. Okay. Thank you. So, till now, what we have discussed is what is cloud and how the data is being categorized into the big data and how the commands will execute when you provide the commands in your computer. We have seen today and cloud computing and correlation of cloud with the computing resources, storage resources, everything we have seen till now. And big data is a problem. What is the solution? Hadoop is a solution. In order to remove the drawbacks of Hadoop MapReduce, we have come up with Apache Spark. Okay, I hope it is understandable for everyone till now. I am going forward from here. So, coming to the Apache Spark. So, as I discussed with you earlier, it is open source engine which can handle batch processing real time system, which means stream processing, and it is interactive, and it is also having the machine learning libraries, everything. And there are few features of a Spark which needs to be remembered by all of us. Okay, in-memory computation, lazy computations, everything. We need to understand what is here we have written in-memory computation. What does this in-memory computation mean in Apache Spark? Means so, in-memory computation means here if you see, this is the Hadoop one and this is the Spark one. In Hadoop, generally how any operation will execute means it will take the data. The CPU will process the command and it will go to RAM and it will take the data from disk. Once first operation is done, again for the second operation also, it will follow the same thing. Go to the RAM, RAM will take the data from disk and then process it and give the answer. Again, for the third also, it will be the same. Every time going to back to the hard disk is a latency issue. Okay, so it is we will be having latency issue because obviously we the data is huge and there will be a latency issue. But when it comes to the Spark, see here, once you execute a command, means see, every time you execute a command, what it will do means uh, we have a set of operations, right? So all these operations, how it will be done means it will go to the RAM. A RAM will process the data, and it will RAM will take the data from the disk and process the data and provide the answer to this one. Every time you provide every time you do a operation, it will be performed on RAM, and at the end, when all operations have been completed, then only it will the data will be again stored into the disk. Okay, so when the data is in RAM, it is very easy for us, and it is easy to retrieve the data and process the data. But when it comes to Hadoop, every time going back to hard disk is really a latency issue, correct? So this is one of the mm, difference between Hadoop and Spark. I hope you all are now aware of what is in-memory computation in Spark. In-memory computation means nothing but see. You need to correlate when you write a sentence. In-memory computation means in RAM it is going to be stored. For every operation, it will fetch from RAM instead of disk. That is in-memory computation. Okay, so you need to correlate in such a way. You write a short notes, but you it is very understandable and you understand it to an extent what I have said. Okay, this is what in-memory computation means. And Spark is also having lazy evaluations. Lazy evaluations means when you read the data, it will read the data, but it will not retrieve the complete data from the hard disk. When you execute any command, means if you perform any operation other than reading, then it will fetch the data from the hard drive. Means mm, the lazy evaluation. The feature is lazy evaluation. It is not listed here, but please take it down. Lazy evaluation means every time you perform any operation other than read, sorry, if it is read, it will not retrieve complete data from the hard disk. Instead, it will read, that's it. It will not store. But if you do any operation other than that, then it will store. Okay, that is lazy evaluation. And let's go to the little bit of history of this is Apache, Hadoop, Spark, and all. Okay, so Spark has been introduced by this person Buckley in 2009. He has Google file system has provided a map reduce paper. Later, Apache has later this person has built this one, built this Spark, and it was open sourced in 2010. And then it was purchased by Apache in 2013. And later, it has become a top level project and world record in sorting, and it is a most active project at Apache. So, and there is one more thing you need to see is this person is has created a Databricks now. Coming to the next one. So the another feature of Hadoop and Spark is this one, sort record. Okay, Hadoop has been tested on 2100 nodes, and Spark has been tested on 206 nodes. And this is the time it has taken, and this is the time it has taken. And here are few things we have listed down: data size of that one time, how much time it has taken, number of nodes, number of cores it has used, cluster disk throughput, and network. Okay, to execute anything, sometimes if the data is less, it will use only one node. If the data is more, it will use how many nodes it require, it will use. Means it is horizontally scalable. That is the Spark thing, and you will further understand this in Databricks also. Okay, coming to the next one. As we discussed it already, it is easy to combine the batch processing, stream processing, and is also interactive computations all in one. It is in Spark. And because it is having in-memory computations thing, it is 100 times faster than Hadoop. Just because of this in-memory computation, it is 100 times faster than Hadoop. Okay. And this is what we have discussed in memory computation. And we also discussed the four languages that are that can be user friendly in Spark is Scala, Java, Python, and R. Yeah. And coming to the next one. How this Spark will be running means this Spark will be running in master slave model only. It is, this is master and these all are slaves, let's say. even the Spark will be running in this manner only. You can correlate the same thing with the Yarn. Yarn is also having the resource manager and the node managers, where the diagrams are similar to this master and slave. So this is how the Spark will also run, and the Hadoop will also be using the same thing. As I discussed previously with you, the only thing you can compare and is Hadoop MapReduce with Apache Spark. Okay. The rest structure of this storage system or this yarn remains same. Okay. If Spark is using HDFS and yarn, it is a standalone one. If it is not using the HDFS and yarn, it is distributed. And there is one more thing which I want to tell you through this diagram is, if the data is coming, this is the diagram for mm, stream processing. You could correlate to the stream processing. If the data is coming continuously, how it will process. You might be having that doubt from long back, right? So how it will do using the Spark stream, what it will do, it will take the data, batches of input data and batches of processed data. Means what it will do means, see, every time the data flows, it will flow continuously. It will create into batches, and it will be able to process all these batches parallelly in the same moment by the time it comes. That is what it has been done here. Okay, hope it is clear to everyone. Am I clear till now? Can anyone answer? Yeah, okay, thank you, Jashwant. You can note these features, why the Spark is being very famous. You can write down these five notes, okay? 100 times faster than Hadoop in memory computation, lazy evaluation, see, lazy operations here we have written, and real time support real time and batch processing. Real time is nothing but the stream processing. Language support is Scala, Java, Python, and R, and multiple transformations and actions. Okay, so you can note it down. This one, I will pause for a minute. Understand the differences of the Spark and Hadoop, and you will be more understanding. You'll get more understanding in both the cases. Why we are not using Hadoop? Why we are using Spark? Understand with the differences. Okay, every time when we do things, it should be like that. Learn from the differences. Okay, I hope you are noting down all these points. I'll pause it for a moment and then I will continue. I hope everyone has taken down the notes, and I'm going to the next topic. You can note this also differences between Hadoop and Spark. First one is architecture. This is HDFS and MapReduce, and this is in-memory processing. Second one is performance. Good for batch processing, and this is for real time. That means stream processing also. It is faster and also capable of stream processing. See, cost. When you use the hard disk, it will definitely the less cost. And when it is coming to the Spark, it is see, there is a difference between lower hardware, higher maintenance cost, higher hardware, and lower operational cost. Every time you do in-memory computations, it will require RAM. It is costly, but it is lower operational cost. But um, overall, when you take it, this is less costlier and this is high costlier. You can note it down simply like that. Don't mess up with these sentences, okay? This is less costly and this is more costly. And ease of use. This is complex and Java focused. This Spark is user friendly and multiple languages. Again, batch processor, real time processing. For failure tolerance, here also we have failure tolerance. It can be handled here also, and here also it can be handled. But there is a difference how both are handling. Here it is being handled because of data replication, and here it is handled because of RDD. What it mean? What is RDD mean? Resilient distributed data set. Okay, we will further go into that one in next half an hour. Don't worry. For now, you take down this one. And machine learning, basic and less efficient, advanced and more efficient. Machine learning libraries, we can take it right. For that, it is only supporting the basic and very less efficient when compared to the Spark. Scalability, it is linear and cost effective, and flexible and memory intensive. Okay, these are all the things we have discussed in our previous slides only. Okay, so I'm going forward. Spark architecture. As I have told you, we have in Spark we have two things. One is master node and other is slave node. Okay, master will assign the jobs to the slave nodes. Master slaves. Okay, this is how it will look. Now we have entered into the most important topic of our concept today, that is RDD. What is meant by RDD? Resilient Distributed Data Set. If this is the fundamental unit of a Spark, you can note it down. RDD is a fundamental unit of Spark. Okay. RDD is simple and immutable collection of objects. I will explain you here. Okay. This is master. This is slave. This is also slave. This is also slave. This is the master one. This is slave one. Slave two. Slave three. Okay. So here the data will reside, and this is RDD1. This is RDD2. Okay. What it means uh, data has been divided among these three slaves. Okay, let's say you have 50 GB of data. 10 is distributed to this one, 20 is distributed to this, and 20 is distributed to this one. Okay, upon all these slaves, you will be having RDD, means the portion of the data. It is a portion of the data. This is one RDD, this is the second RDD. Likewise, you will be having number of RDDs. When you execute something, every time it will search the data with respect to RDDs, means the data is divided into three nodes, and then again the data has been partitioned with respect to RDDs. There is a difference, distributed and also partitioned. I'm repeating it. The data has been distributed and also partitioned. With respect, the things which are partitioned are RDDs. Okay, these RDDs cannot be altered. Instead, you can create n number of RDDs. Okay, this is how it will maintain the fault tolerance, because it cannot be altered. When you don't have permission to alter it, there is a security for the data. Okay, I'm going to the next one. See, this is what I have told you. RDD partition 1, 2, 3, 4, 5, and 6. And this is master and this is slave. These are all our slaves. And again, slaves are partitioned into partition 1, 2, 3, 4, 5, 6. Okay, this is how it usually be. RDD is a resilient distributed data set. I will explain you each and every word of this one. Resilient. What does this resilient mean? The resilient meaning fault tolerance, and distributed data is stored in multiple nodes. That's why this is distributed data set. Collection of partition data is a data set. See, fault tolerant data stored in multiple nodes and collection of partition data. This is RDD, resilient distributed data set. I hope this is clear, right? I hope this is clear, right? If no, please message here. I will repeat it again because this is a major concept. Can someone answer yes or no? Can I go forward? Am I audible? Hello? Repeat. Yeah, sure. See, in the Spark, data has been stored in master slave manner. Master will be master will not do anything. It will just assign the work to the slaves. That's all. But if you have a data of 50 GB data, let's say 50 GB of data, 10 GB of data will be stored in slave 1, 20 GB of data will be stored in slave 2, 20 will be stored in slave 3. It all depends on how it works. Okay, it is not every time this will store 10, this will store 20, this will store 20. Okay, it will always depends on how much data you are processing and how many nodes you have for processing. It all depends on that one. Okay, firstly, data has been distributed among the slaves. Write it down. Data, firstly, data has been distributed. Secondly, data is partitioned. Once the data has been distributed, data is partitioned. Data, those partitions are called RDDs. Okay, through these slave 1, 2, 3 are distributed. RTD 1, 2, 3 are partitioned. I hope this is clear now. If not, ma'am, could you please explain about the difference between the name node and the data node, master node and the slave node? Okay, master will not do any work, Kartikeya. It will assign work to the slaves only. Means when the data is when you execute any operation, what it will do, it will be getting the data, processing the data, and it will be all the things will be happening in slaves only. It will be only collecting the results only. It will be assigning the task, and then it will be taking the result from the slaves. That is what the difference between master node and the slave node. And the other one you asked me is name node and data node. Name node and data node, I think I didn't discuss this one. In Hadoop, it is not master slave. It is one is resource manager and another one is node manager. There also the operation is same, but there the data has been replicated just by distributing it and replicating it. But here, if you see this diagram, these are called RDDs. Means it has been distributed in this way first. Okay. And again, it has been partitioned like this. First 50 into RDD1, next 100 into RDD2. Likewise, it has partitioned. Hmm. I hope this is clear now. Kartikeya, to you, master node and slave node, node manager and resource manager. Please answer yes or no. Yes. Okay. Good. Now moving to the next one, creating the RDDs and the Hadoop clusters and all. RDD mainly have three operations. One is transformation, other one is action, and the third one is persistence. Now let's discuss about these three things. These are the major concepts. Okay, please don't allow me to go to the next topic until you understand these topic clearly. Okay, RDD operations, what is meant by transformation, what is meant by actions, what is meant by persistence. Now we are going to discuss on this one. So what is transformation? Transformation means filter, group by, map. All these operations are categorized to the transformations. And action. What is meant by action means it instructs a Spark to perform the computation and send the result back to the driver. Okay, that is action. In your own language, how you can say means when you, let's say in SQL, you have written some query. Okay, in that query, you have done some transformations. Means you are changing, you are altering something, or you are adding some data, or you are inserting data, or something you are doing that comes into the transformations. When it comes to actions, what does a action mean? When you perform this thing, select star from table 1, what does it mean? It is an action. It is collecting the data, and it is showcasing you what data you asked. It is showcasing that one. That is action. You clearly understood, right? What is transformation and what is action here? Now let's go to the persistence. Persistence means, see, sometimes what it will happen means, you have 30 GB of data. Okay, you have 30 GB of data. Every time you execute an operation, what it will do, the CPU will process the data in RAM, and RAM will take the data from the hard disk and it will be stored in RAM, right? So every time means you are taking the data again and again and again, means you want the particular table data multiple times and you are going to use it multiple times, then that data has been stored in persistence, means it will be stored in RAM and remaining data will be stored in hard drive. Okay, means it will categorize. See, when it is being taken multiple times, then the data will be stored in RAM. Then that property is actually called persistence. I hope this is clear. Please answer yes or no, whether you are clear with these three actions, transformations, and persistence. Please say yes or no so that I will continue. Yes. Okay. Thank you. I'll be going forward. Transformations. Take this diagram. Okay. RDD operations, transformations, actions, and persistence. Transformations. It will perform the operations like filter, group by map, and all. Actions. It will instruct the Spark to perform the computation and send it the result back to the driver. Actually, persistence. Persistence is the one which uh, which decides whether the data should be in RAM or the data should be in hard drive. Okay, moving forward. Now, RDD operations in transformations. See, here we have clearly given set of operations that define how RDD should be transformed. You can note all these points of for transformations, actions, and persistence. Okay, for your future reference. Transformation, set of operations that define how RDD should be transformed. Creates a new RDD from the existing one to process the data. Okay, it will never alter the existing RDD. Take it in a bold letters. It will never alter. Instead, it will only create a new one out of the old one. This is the most important property. Because of this property only, it is a fault tolerance, means failure resistance. Even if the system has been crashed, you can backtrack all your source codes because of this particular property. Okay. Lazy evolution computation does not start until an action is associated. See, what I told you, uh, read operation, if the read operation has been done, it will never retrieve the data. Other than read operations, if you perform a operation, then only it will retrieve the data and present it to you what you are expecting. Okay, so these are the operations of transformations. These are some examples. Okay, map, flat map, filter, union, group by, etc. So take down the complete points what are listed here with examples. Okay, we will be moving forward. We will be discussing more about all the functions of transformations, all the functions of actions, everything we will be discussing now. Okay, this is about the transformation. I hope you have taken down the notes. I'm moving to the next one. This is the action. Action. What action will do? It actually triggers the job execution, returns the result, or write it to the storage. So, examples of actions are count, collect, reduce, take, etc. Okay. Collect. The function it says collecting the data. Count, it will count and display you what it is. See, there are few things which you can correlate with your SQL, because In SQL, when you write select star from table 1, it will display the data of the table 1. In that case, you can correlate that with the action. Transformation, when it comes to transformation, let's say how it goes means, mm, when select gender from table 1, sorry, count of gender from table 1 group by gender. If you do like that, then female or male, how many are there, we will get both the gender counts. Okay, gender comma count of gender from table 1. So you will be getting both of them with group by. If you do group by is a transformation, and you are also displaying these results by using select statement. So select statement will be an action and group by statement will be a transformation. I hope this is clear to everyone now. Please say yes or no. Actions and transformations with examples. I hope you are clear, right? Anyone? Yes, okay. I'm taking this as yes and going forward. Persistence. Spark allows caching persisting entire dataset in memory. See, sometimes the data, entire data is needed. Sometimes only the portion of the data is only what you do every time. I mean, you do execute operation on only the part of the data. Then that time that part of the data will be only resided in RAM. Rest all will be in hard disk. But sometimes you need each part of the complete data set, then everything will be resided here. This is what the persistence means. I am telling you once again what is persistence. Persistence is a property of RDD, and what it will do, the portion of the data or the data which is required every time, that will be stored in RAM, and the remaining data will be stored in hard disk. Okay. I hope this is understandable to everyone. Going forward, see, this is a diagram of the RDD, how it is actually, the parent RDDs and the transformations. Map, flat map creates a new RDDs based on the custom business logic, and again giving the data to RDDs, creating a new one. When it comes to action, it will just take the things and provide the results. See here, in transformations, you will take the data and create the new RDDs, performing operations and creating the RDDs, many more RDDs. This is how the transformation looks like. And when it comes to action, it will just take the data, display the result. That's all. Please take down this diagram. This is more understandable than what is written before, I hope. I hope this is done. I'm going to the next one. I hope everyone are taking notes of the major things which I have told you till now. Because see, today when I'm explaining, you understand everything. But tomorrow we will be discussing the other topics which is linked to this one. So every day you come to class, before you come to the class, just take a brief of what we have discussed yesterday and come to the class. It will be easy for you to correlate the things how previously it is and now from which point to which point we have come today. So you need to correlate all the things throughout the course. Then it will be easy, understandable to everyone. This is not something which you cannot understand. This is really simple and easy. This is all the background of architecture and all, okay. But basically what you do using this Databricks is you will be writing the code in all these four languages. But how the how it is taking the data and how it is analyzing, how it is processing, what are the drawbacks, you need to understand. For better performance code, you need to understand all this. Because unless you don't understand the basic concepts of all these, you will never understand what is the issue. Means sometimes you will be getting the performance issues. Means you execute a query and it will take much more time and it will be consuming all your nodes in a cluster. Okay, means cluster nodes. What does it mean? Means in Databricks, you will be having a cluster. Each cluster you will be having a nodes. Okay, every time you perform, every time you execute something in Databricks, it will take how many nodes required, and then it will release once the whole notebook has been completed. I mean, the whole operations has been completed. This is what it is. So if it is taking much more time, then you need to analyze like, okay, so these are the things need to be taken care. Like you need to go, you need to understand like, okay, because of this transformation logic, this has been created multiple RTTs, which is not required. This is the action which is giving the wrong results. So this is how you can understand in further, right? SQL, Java, Scala, Python, these are the four languages you can integrate with the Databricks. So you will be writing any one language in the Databricks and you will be executing the things, okay. For now, in our course, we will be learning Spark with SQL, not the Java, Python, and Scala. We are going with the SQL. So, we will be dealing all the things in SQL only. You will be surprised. See, this is the same SQL code which we have written in our lab, and the same thing we are writing here. But what is the difference? In your lab you might be writing on a on premises one. Means you might be writing on Oracle or whatever the software your college has taken. Using that one you are performing. Now you are using Azure Databricks. It is a cloud one. You are writing something in cloud. That is the major difference you could see. By the end of this session, you will be understanding each and every point of this Spark, Databricks, and the complete system of this Databricks and the Spark. When I hope SQL has everyone know what is SQL, and you might be if CSE and IT, you are from CSE and IT, you will be knowing the SQL previously. But for other department students, that's fine if you don't know SQL also. In our course, we will be going from the ground level. Okay, so no need to worry on any of the hurdles you will be getting. I'll be here and you can ask me any question anytime. Okay. So these are the features of the Spark: speed, duplicate elimination, processing, window criteria, fault tolerance, and memory management. As discussed previously, we can remove the duplicates. See, Hadoop is having the duplicate data. I mean, I'm not saying duplicate data. Fault tolerance can be handled in Hadoop through replicating the data. But here we are handling fault tolerance using RDD. Okay, you must have understand this point today clearly. Okay, Hadoop is 100 times faster. Sorry, Spark is 100 times faster than Hadoop. Why? See, you here I have given the features of the Spark, but you need to understand. Okay, this is a feature, but this feature has been implemented for what drawback of Hadoop? You need to question yourself for which drawback of Hadoop we have got this feature. You need to understand in such a way. You need to correlate both Hadoop and Spark in that way. Okay. And memory management, automatic memory management. As I said, it will go on increase and decrease based on what you have given, based on the data size and all. Okay. Fault tolerance window criteria. It is a time-based window criteria. So um, now that we are in the end of the session, I will recap all the things what we have discussed in today's session. Okay. In next 5 minutes. Firstly, we discussed about uh, what is cloud and what is cloud computing mean. Second one is what are the types of cloud computing and the subtypes of the cloud computing. And the third one is how the data flow from storage to CPU. This is what we discussed, and everything revolved around this particular thing in Hadoop and Spark till now. I hope you are good now. If anyone asks you how it works when you give a command, how it executes, you will definitely now able to tell, okay, this is the processor and this will give query, and then from the hard disk, the RAM will take the data and it will process and it will provide again output to the CPU, and CPU will output to you. This is how it will be going. You will explain from now on, right? And if this can be done in your system, but if the data is beyond what you are expecting, even if it is a terabytes of data, see, in real time you will be seeing the gigabytes of data, terabytes of data every day. Because see, all every day you go somewhere to register to this course also, you will give your ID number, mobile number, and everything. You will give your information. Starting from this point, you can correlate many things. Every day you have huge data in your hand, where it is going, how it is being processed, why there is a why there is a chance of integrating our things to the cloud, why there is a need. You need to question yourself and answer it, because it is very important when you correlate it to the real time scenarios. Okay, we have many real-time scenarios. I will be randomly asking you the questions tomorrow before starting the session, whatever we have discussed today. Okay, today, every point what I have discussed and what I told, it is very important. Whatever you have written in your notes, tomorrow I will be asking you. Okay. We have discussed about cloud computing and data flow from storage to CPU and big data. How we categorize the data to big data. We have checked that one as well. And what is the problem? Can anyone answer what is the problem? Ma'am, can you click the slides in WhatsApp group? Sure, sir. I will keep the slides in WhatsApp group. What is the problem and what is the solution we discussed today? Can anyone answer quickly? Spark. Okay. Spark is what? Big data. Big data is what? Problem. Yes. Problem is big data. Correct, Sampath? Spark is solution. Huh, huh, huh. Yes, why Spark? We have taken all these notes today. See, Spark is also solution. Hadoop is also a solution. Initially, we have Hadoop in our hands, and then upon removing the drawbacks of Hadoop, we have implemented the Spark. So yes, we have discussed Hadoop as a Spark today completely. That is the major concept which we discussed, and we all have checked each and every drawback of Hadoop. Okay. On seeing this response, I'm very happy that you all have understood it to the roots of the concept, because you